Okay, so today we're going to be talking about glass fiber reinforced concrete, or GFRC, also known as GRC, which is just glass reinforced concrete. So the basic design of this is going to be some dry ingredients and wet ingredients, and we're going to get into the basics there. But what this can achieve is to do concrete laminates or castings and keep it fairly thin but super strong. So really ideal for doing countertops, tabletops, and with adding this glass fiber reinforcing into it, it gives the concrete laminate a little bit of ductility as well. So it's not going to be brittle like you typically find with concrete. So really special mixed design. So I'm going to go through it now quickly. On the dry ingredients, we've got white cement. You can also use gray cement. And this is a 52.5 type 1, so very good quality cement. On the silica sand, that's basically a 0 retention on a 20 mesh sieve, so a specific grade of silica sand that we've got here. And we've got the alkaline resistant glass fibers. So very important to use alkaline resistant fibers because in the cement, it's very alkaline. And if you use standard glass, that's actually going to be corroded over time. So very important to use alkaline resistant glass. And we've got water, which is just fresh potable water. And we've got our resin. So on the resin, we've actually got two different types that you can use. We've got a very special resin called 4-ton VF774. And it's been around for a very long time and has a 20-year case study history. So if you're doing architectural applications, certainly better to go with the 4-ton. That's what we're going to be working with today. But if you're doing some home projects, you want to do a tabletop or a countertop, we've also got our GFRC resin, which is a very basic generic resin system. It's quite a bit cheaper, but does the job quite nicely for smaller type projects. So yeah, let's go through. The mixed design that we've got, which we'll have on our website, we've got 1 kilogram of cement. We've got 850 grams of the silica sand. We've got 66 grams of our glass fiber, 270 grams of water. That proportion can be from 240 to 270 grams. And we've got 120 grams of resin here, and that can be used from 100 grams to 120 grams. And then also a very special ingredient is our super plasticizer. So this is also known as a water reducer. And what this does is allow you to have a fairly nice mix, have it nice and flowable, but using as little water as possible. And what that does is allows you to have a more consolidated, compact mix, which will reduce the chance of cracking and also give you quite a nice bit of strength to it as well, increase the strength. So the plasticizer, although we're only using a very small amount, has quite a big effect on the flowability. So that's the super plasticizer. So the process that we're going to be doing here is going to be basically 2 steps. We're going to be putting in a face coat into the mold, and that face coat we then let dry. And the reason why we're doing it in 2 steps, that face coat that we put in, we're not going to incorporate any of the fiber in the face coat. We're just going to put it in without the fiber, and then we're going to let that dry. And then the second step is basically to do it again, but with our reinforcing. The reason why we don't put reinforcing into that first step is we don't want that glass fiber to be visible on that surface layer. So it's just purely the resin. For this demonstration, we're just going to be actually brushing that face coat or that surface coat into the mold. Nice for small applications. But if you are doing large applications and big tables, you can also spray that surface coat or mist coat into the mold. So this is a hopper gun. You can get them, they're not too expensive. Hook it up to a compressor, and you can just put in your mix also again without the glass fiber. That's just purely to spray that first coat into the mold. Okay. So I'm going to get the process going. It is quite important to follow the right steps when you're putting the mix together. So to start off with, we're going to be putting our liquids together. So we have our water and our resin. We're going to add those. As you can see, I've got 2 batches here. The smaller batch is going to be for the face coat. On the plasticizer, we're just going to start with half the dosage. So I've got about 3 mils here. We're just going to go in at about a mil or 1.5 mils just to start. Very small amount. And then once we've mixed, we can just gauge if we need to add more plasticizer or not. And the next steps are going to be to basically add the dry ingredients. We're going to add the silica sand. If you want to add pigments, you can also add pigments into the liquids and get those dispersed. We're just going to do this without the pigments. So our silica sand going in. So we can give that a little bit of a stir. I think this container is going to be a bit on the small side, so I'm actually going to transfer across that into a bit of a bigger container. Otherwise, we're going to be going over the top here. Okay, so that's our silica sand in. And then we're going to actually add across our cement. And this we can do gradually. So I wouldn't always suggest putting the whole lot across straight away. We're just going to put probably about half in to start and just see how that goes with the mix. And for the mix, I have got a variable speed drill. So, and I've got a shear mixer attached to that. Sorry, just a bit tangled up here. There we go. Very useful little tool to mix this up. That's looking quite good. You can add the rest in. Just going to give the sides a bit of a scrape. I think the consistency is actually quite nice. As you can see, it is flowable. You can also take this mix as it is and you can actually cast it into silicone molds to do some lovely castings that has fairly decent strength. So I think, just remember, if you're applying it into a silicone mold that's got a lot of intricate detail, you actually want this mix to get into all that detail quite nicely without entrapping bubbles. So you do need a fairly low viscosity mix, but I think this will be fine as it is. And then we've just got some water on standby here just to clean out our mixes. There we go. All right, so we're just going to start putting this across into our silicone mold. There's quite a bit of detail in the silicone mold, so it's not quite as easy as just pouring it in and letting it do its thing. We're actually going to get a brush and we're going to stipple it into the detail. Obviously, if you're spraying it in, it's quite nice because spraying it in is also going to help force it into all this fine detail. If you don't take time doing this, you're going to land up with a lot of air bubble entrapment, especially on those little sharp corners in the detail. So I'm just going to give this a bit of a tap to settle down into the mold and just go around the detail once more. A little vibrating tab will also do the trick very quickly. And then just another quick brush around. Remember, this coating that we're putting in here is just what they call that phase coat or mist coat. And it's also just purely to stop the fibers from being visible later on in that surface coat. I've got a hair in here. There you go, get rid of those as well. I think I'm going to put a touch more. It's a little bit thin around the edges here, so a little bit more. And that's it. So I think that looks absolutely fine. You can also just rinse the brushes out in water as well, so you can reuse the brushes again. So just to recap, yeah, spend a bit of time, if you have got a lot of detail in that silicone mold, spend a bit of time to just work it into that detail so you don't have any little air pockets and things. And again, what we're going to do here is just wait for this to become touch dry. That period of time can change a little bit. Obviously, it's going to be affected a bit by your ambient temperature. If you've got a nice warm, dry day, that's going to be quite quick, probably within about 40 minutes to maybe about an hour. If it's going to be a bit of a cooler day, you might even be an hour and a half or 2 hours for that to become firm enough before applying the reinforcement layer. So yeah, we're just going to let this dry up a little bit, and yeah, we'll come back to it just now. All right, so we've left this for probably about 30 to 40 minutes, this face coat that we put into the mold, and we're ready to do the reinforcement layer now. So just another little point, when you do that face coat into the mold, if you're doing something small, you can have it on a board so you can move it around, but be careful not to move the mold around while that face coat is curing, otherwise you're going to have a crumbled face coat. So this next step, as I mentioned, is going to be the reinforcement section, and this is where we're going to use exactly the same mix as we did for the first coat, but we're going to incorporate the alkaline resistant glass fibers. So we've got our 18 mil fibers, and what's quite important is that we want these fibers to be as flat as possible for the ultimate strength. So if we put some of these fibers down on the surface like this, that's kind of the orientation with these fibers being flat that we kind of want to have in this mix. So the typical laminate thickness that you can do with this GFRC is probably 20 to 25 mils. You can go thinner than that. This piece is going to be about 10 mils. And what you want to do is each layer of this reinforcing you put down, you don't want to exceed about 9 to 10 mils per layer. You can go up to 20 mils, but just do it in 2 stages. And that's to try and keep those fiber orientations quite flat. And that's what's going to give you optimal strength in this mix. So yeah, ready to go. I'm going to actually mix up the products again, just the liquids together. So I've got the water, the resin, so all our liquids together. Again, we're just going to do half the plasticizer. So I've got 6 mils here. So I'm going to do 3 mils of plasticizer. And in goes our silica sand. And then we're just going to gradually add in the cement like we did last time as well. Do about half, and then half again. What? Just going to scrape the sides of the container here. Our consistency looks quite good, so I don't think we need extra plasticizer at this stage. But as I mentioned, if this consistency looks a bit on the thick side, you can add a little bit more in. Just going to wash the mixture in the water. And we're going to add the fibers. So the fibers, we can kind of also just gradually stir those across. You can use a shear mixer to incorporate the fibers as well, but I normally suggest then to just be fairly careful and do it on a bit of a slower speed, as you don't want to fracture those fibers and break those fibers up. You want to keep the fibers whole and intact for the optimal strength. And that's our GFRC reinforcement layer ready to go. So this is touch dry. perfect for adding our next stage, and that we can just get across. Actually, it's got a bit of nice flowability to it as well, which is great. If you want a slightly thicker consistency, that can be done by just using less of the plasticizer. And also on the liquids, I spoke about the water being 240 to 270. You can also just reduce down the water proportion a little bit as well if you need a bit of a thicker consistency. So I'm just being quite careful getting it into the corners of the mold here. These glass fibers are visible in the mix. I can see them on the top here. And I think that is just about it. It's just below the mold surface. So for a smallish piece that we're doing like this, the reinforcement that we've got in here is going to be plenty strong enough. But I'd also like to just demonstrate another reinforcement that we've got, especially if you're doing larger surface areas like a tabletop or a countertop. We also have alkaline resistant Duramesh scrim. So we've got this in two sizes. We've got this, which is a 10mm aperture, and then we've also got a finer 5mm aperture as well. This has got double amount of glass in it, so it'll be super strong. And this, you can just put it at the end, and that really helps with a bit of extra strength on this piece. As I mentioned, it's a bit of an overkill for the small little section that we're doing, but if you're doing a countertop, tabletop, this would be really good to put in. So we can just incorporate it across the back. And we can use our brush and just get that slightly below the surface. This Duramesh scrim has been in a roll, so it's not lying perfectly flat. But if you are going to use this, it's better to kind of unwind it, leave it flat overnight, or put a bit of a weight on it. Just that helps to flatten out this Duramesh scrim and make it a little bit easier to work with. So that's the Duramesh scrim that's been incorporated at the back. So there's still a very couple of important things at this stage. The one is that we don't want this to actually dry too quickly. We want it to hydrate and for the resin to cure. So very important at this stage. You could leave it for maybe 15, 20 minutes to firm up a little bit, but very important is to actually keep the piece wrapped in plastic, and that plastic will actually keep it hydrated. And it's best to keep it hydrated like this for probably about 16 to 24 hours. And then at that stage, you can demold out of the silicone mold. And then it's also very important for about a day to air dry this piece. And very important, when we air dry it, we want the air to be exposed to all sides of this piece. So we can put a couple of strips of wood down and then put the laminate on top of those strips of wood. And we just want to be able to air dry around the whole piece. If we've done, let's say, a tabletop, might be a square meter tabletop, and we put that down flat onto the ground to air dry, what will happen is we have the top hydrating a bit or drying out a little bit quicker, and the bottom actually staying damp, and it'll actually cause a panel to warp. And that's called a smiley or a frowny, but it's normally a frowny, as we don't want that to happen. So very importantly, as I mentioned, some strips of wood down and let that piece hydrate and dry out nicely on both sides. And that is the glass fiber reinforced concrete process. So here we have a GFRC panel. As you can see, this panel is quite thin, probably only about 8mm thick, and super strong even in this thickness. That came out of this little silicone mold over here. So this is a TinCure silicone mold, Mold Max 30, and the whole main reason for using glass fiber reinforced concrete is so that we have the fiber reinforcing in to do thin, lightweight pieces that have some really good strength. So the average laminate thickness is typically about 20 to 25 mils if you're doing a tabletop or countertop. But there's many other things that you can do with GFRC. You can do wash basins, you can do fireplace surrounds, outdoor furniture, you can do planters like pot plants, and keeping your material nice and thin but super strong. As mentioned, very important through this process to use alkaline resistant fibers. If you use standard glass fibers, they will break down in the alkalinity. The alkalinity will attack those glass fibers and it'll actually start to corrode them, and you can actually have those panels failing. But yeah, if you're using alkaline resistant glass fibers, it's perfectly good. We have two resin systems. We have the Forton VF774, which is a really top quality product. It gets used for all sorts of applications we've just spoken about, but also for architectural cladding. And if you are going to be doing architectural cladding, I would stick to the Forton VF774. It's got a 20-year case study history and spec for those applications. If you're doing some smaller projects at home, we also have a product called GFRC resin, and that's a little bit cheaper and does pretty much the same thing, just not on the same kind of level as the Forton, but really good if you're doing tabletops, countertops, wash basins, works perfectly good for those scenarios. But as I mentioned, if you're doing anything architectural, going up in buildings, I would stick to the Forton VF774. And yeah, that's kind of in a nutshell the GFRC material and process. Okay, so for doing some home projects, we do have some little starter kits available in the glass fiber reinforced concrete. As you can see here, we've got a bag of cement. This is 10 kilograms of cement. We've got 8.5 kilograms of your silica sand, 700 grams of the AR glass fiber. We also have the resin, the Forton, as well as the GFRC resin available in a 1 kg, and then also a small quantity of plasticizer. So if you're wanting to tackle a small project at home, you can start off with one of these little starter kits. And yeah, as I mentioned, the GFRC resin, I would probably stick to the 12% of the cement portion, which is 120 grams of this to the 1 kg cement. And if you're working with a Forton VF774, this has got a higher solid content. You can go in at 10% of the cement portion, which is going to be 100 grams to a kilo of cement, or you can also go up to 120 grams here if you need to as well. And that's our little starter kit. If you're adding color to your glass fiber reinforced concrete, we have got some oxide pigments that you can use. There's a small selection as you see up front here. The dosage of your oxide pigments is typically 2 to 6% of your cement portion. So if you go back to your 1 kg of cement, you can add that 2 to 6%, which would be 20 to 60 grams of your oxide powder. And if you want a very strong color, like a nice deep black, then go for the higher 6% dosage. Sometimes these pigments do have some little clumps in them. So I found that if you want to get rid of those little clumps, you can actually mix the oxide pigments into the silica sand. So you can do a dry mix of those pigments into the silica sand. And by doing that, you actually, the sand breaks down those little clumps and you get a fairly good dispersion of the oxides, into the mix. Yeah, they're pretty good in terms of being color fast and UV stable, and you can create some nice different shades. All right, so once you've got our GFRC piece, we've also got a very nice concrete sealer that you can apply onto this to give it a bit of a better wearing surface. And it's a product called Concrete Sealer Crystal Gloss. It's a one component sealer, so don't need to mix anything together. You have to be a little bit careful. It does have quite a strong solvent in it, so if you are spraying it, just make sure you are looking after your lungs with a respirator. You can also apply it with a brush or a roller. It does flash off very quickly, so the working time on this, if you are applying it on a warm day, it's going to start to set up quite quickly. So this is a piece that has been actually sealed with the concrete sealer. You might pick up a little bit of a gloss finish on that. So this is just basically one coat of the concrete sealer. You can put 2 coats on or 3 coats. It's going to build up that glossiness a little bit if you do that. And then we also have this piece which hasn't been sealed, and that you can see a little bit more of a matte finish. But definitely the concrete sealer will keep parts sealed up nicely. And if you're washing them or cleaning them later, it's going to wash off much, much easier. This concrete sealer is a water clear color, and it's also very good in terms of being UV stable and staying clear as well, and not yellowing. So that's the concrete sealer. We've got this available in 1 liters, 5 liters, and 20 liters.